Hey guys, this is Eric Wangan with Wangan Racing for another video on this Assault Kmj head as far as porting goes. This is going to be pretty much it. There's one more thing I'm going to do after this, but the port itself right now, and I'll show you in just a second what I'm talking about, but the port where it is. So there's not much more grinding I'm going to take out of it. Now, I'm going to go ahead and preface this by saying whenever I flow it, I have had this head flow more than this one, but this one's going on 350, maybe turning 6,000, 6,200 RPM. Yeah, I don't need it big. So flow is not everything. And you can easily make things flowing higher if you make the port bigger, which makes it look good on the flow bench, but doesn't necessarily make more power. However, what you want to do is, try to get as much flow as you can for the size that you need, as long as the port velocities inside the port are correct. That's probably going over your head, but the point I'm trying to make is, yes, I can make this head flow a bit more, but it won't make this engine that it's going on perform any better and may actually make it worse. But I'll show you what's been done since the last video. So the only thing I really done on the port is this. This is right here is the opening. So let me explain. I used a 1205 gasket to gasket match it. So there's stock and that's this. It doesn't look that much different because it's not. So in case you're wondering what's the difference in 1205 or 1206. Okay, I've got the gasket stacked. Okay, this is a 1206 gasket right here. I'm trying to get them lined up as much as possible. There you go. So you can kind of see how much bigger it is. The 1205 is actually the one underneath. I'll show you in a second. Most race heads will use a 1206 gasket. More of the street heads, like your performance, mile performance heads, use the 1205 or even that blue print seal one from Felpro. Majority of race heads use a 1206. Very common. So anyway, I didn't want to do that because the intake manifold that's going to be bolted to this head will be the Edelbrock Performer EPS, which is really small. I'm not even entirely sure if I can port match it to a 1206 because I'm not sure if there's enough material to make that happen. It doesn't need to have a big opening anyway because it kind of makes no sense for you to put a 1206 opening here, or one that's taller and wider, when you're just going to shrink it down right here at the pushrod pinch anyway. In other words, all you do is make the opening bigger, but this is still the same size. So 1205 it is. It should seal up fine. So in case you're wondering what they look like, this is the 1206. This is the 1205. If you're ever trying to figure out which one they are besides the part number, the 1205 has this notch down. 1206 doesn't. Anyway, this is the gasket to be used. I did open up the pushrod pinch slightly, more so to make it more aesthetically pleasing, I guess, because I needed around it because there's some bulges here, which you can't see until you start grinding, but there's one right through here. But I did want the pinch slightly bigger and just to make it go with this. So the pinch went from a 2.05 CSA before, now it's a 2.14. The only thing I really increased was it went from 0.992 wide, that's from here to here. Now it's 1.04, so it's slightly wider. Most of that's just because I'm trying to make it round better. Anyway, if you're doing a true race head, you want way more area than this, and that's why the 1206 is probably better. It's just not needed for this one. But it's interesting to see if it actually flows more. I've already flowed it, before. I've done steps, and you've seen me flow it with just doing the bulwark, short side, just the vane, just the chamber, just the valve job. This will show me just what doing this part right here does. And that's still quite a bit of big difference. So 40 thousandths, a little bit more than 40 thousandths has been removed from the width. So, and the cross-sectional area at the pinch did get, quite a bit bigger. Does it actually flow more? Well, we're about to find out. So I'm gonna flow that. Now, also, let's go ahead and talk about the exhaust. It's real hard to do the exhaust in steps. So what I did is I just finished it out. So before I had done the bowls all done, and then, by the way, it's still roughed in. That's why it probably looks like crap. Because it's just rough. The shape's right, it's just not beautified. But here's what the port looks like. For some reason the light's not capturing it right. Anyway, that should give you a better idea. So that's what the port looks like. I'm gonna try to get it where you can see the short side. There you go. This is not finished, but as far as like the major grinding, this is done. I'm not doing it anymore. And you can kind of see how much bigger it is than the one next to it. All I did really was make it a little bit more rounded here, a little bit more rounded there. I really didn't want to make it too much bigger. You can actually port this opening and make it bigger and it'll flow more. The catch is I know that the headers that are going on this are 1 5/8, so it's pretty small anyway. So again, I could make it big and flow really good on the flow bench, but the headers won't support it anyway, so it's kind of pointless. But the point is the exhaust port's done. All I did was from the last video after the bowl, brought it out here, opened this opening here, brought it down a little bit here this way, and then did the short side, which, like I said, you can kind of see. And that's pretty much it. Now there will be one more video after, well, 2 more videos. The next video, all I'm going to do is take it from this and I'm going to just make it presentable. So I'll have a cartridge rolled finish and we'll see what it changes on flow. And the last video I'm going to do is something that you can't do at home unless you have a valve refacer. I'm going to change some of the back cut angles and widths to see if those actually affect flow. So here we go, back to the flow bench for one more try. Okay guys, I'm not sure how I linked these, but I saw some errors like as far as how the picture looked in some of the other videos. So as far as showing differences in flow sheets, so I just printed one out to kind of show you. Anyway, I'm going to go over the results and changes it's having this time. So we talked about opening up the push rod pinch and how much it gained or lost. Well, here's what it is. So the cylinder 5, if I look at my notes here, cylinder 5 is where we left off, which was the bowl throat short side. Exhaust bowl is half done. So if you look at this, this is, by the way, on this one, the exhaust is finished, done. So this one's kind of weird because this one's exhaust all done. But on the intake side, if we're looking at it, it's just the only thing that really got done or changed was the push rod pinch opened up. So if you look at it, and these are the differences. So this is before and this is after, and this will show you how much it gained or lost. So it lost there, gained quite a bit here, lost a little bit there, actually quite a bit, lost a little bit there, then gain, big gain, gain, big gain. It's almost flowing 300 CFM. Now granted it's 800 lift, but still look, it's 289 right now at 600. So for this size head, that's pretty good. So a good pickup as far as just open up the push rod pinch. Now I should point out, it makes it sound like the most important thing you should ever do is the push rod pinch, but I don't say that. This was just done in stages to kind of show you how to port the head so you could do it on your own. So I know these are cheap heads and I know guys could want to do this on their own and wonder what they can do to help. But anyway, if you just did this, I should have probably just ported this part first, and maybe I'll do that on a different one later in another video. Just do the pinch and you'll see it doesn't gain CFM like this. The only reason why I did it is because downstream was kneading the air and it was choking off what it had there. So anyway, what I'm trying to say is just if you just do the pinch, you're probably not going to see as big of a gain as this if you didn't do any other bowl work and stuff. But anyway, regardless, very good. Now on the exhaust side, it's really hard to show you what all has been done, but now the short side's all done. The exit's opened up, so the exit got bigger, and it's pretty much where it needs to be. The only thing left on these is these are both like burr finished, I guess you could say, and the next step would be to smooth it out. And but so that'll be the next test you see is how much CFM's gained whenever you go from this is a truly rough finish to a 60 grit finish, which is not necessarily smooth, but it's definitely more done than that. I should point out too, it makes it look like the textured finished, the 60 grit is far superior whenever you see the next test, but it's more that it's smoothed out the lines in between what the grinding does, so it kind of puts things together. So that has a pretty good part of it too. Anyway, on to the next thing. Okay guys, back again. This is like the last bit of port work I'm really gonna do. I just really quickly just did this. I really don't have much time, but all I did was go from and I'll make it look good when it's all said and done. This isn't bad, but this is definitely not up to my standards. But this is just trying to get it done. All I did was just use a cartridge roll and just kind of smooth up the rough pieces, and we'll see what it does on the flow bench. Yeah, so it's all there. But anyway, I'm getting ready to flow it. The only other thing I'm gonna do after this, so this is pretty much the only, no port work has been done beyond last time. Just quick cartridge roll, had about 5 minutes, get this done. Usually what I'll do after this is use a flapper wheel on a 60 grit just to kind of make it look more presentable. I don't even know if I'm gonna do this because this is for like my sister's engine. She doesn't care, I don't care, but it does look more presentable to a customer. I would never send a head out like this. But anyway, I'm just gonna flow it and we'll see if the finish itself made any difference. It should make some, and not necessarily because it's rougher or smoother. It's because whenever you do this, typically, like I did a cross cut first. So let me back up. I did aluminum burr first, which makes it pretty rough. The cross cut will then bring it together so the lines get smoother from where you've been grinding. So there's not so much waves, in other words, in the port. And then of course there's a pink stone that's left that's like 24 grit, and then this is 60. So that brings those waviness pretty much flat, so that everything should flow just slightly better, but maybe not. And we're gonna do this. The next thing I'm gonna do after this, just back cut on valves, and we'll see if it makes any difference. And then the last and final thing is, so far I've been flowing on a 430 bore, because that's the engine that's going on. I'm gonna flow it on a 4155 bore and see if it makes a difference. And then and that was gonna be the last, but I'll probably actually flow it on the Super Flow too, just to see if it makes any difference there too. All right, off to flowage. Okay, now this is test number 7, 6 compared to 7. 6 is where we left off with just the pinch opened up. 7, the only thing that's been changed is I cartridge rolled both. Now we broke 300 CFM, which is a pretty good deal. Because you remember right, the FR10 did not break that. So my goal was to get it to break that head. Beat that as far as flow. Now, granted, it's not doing it, especially here and some of the other points. But, hey, it's small things. This head's pretty cheap. I mean, and also, by the way, I know I can get more flow out of it, just make it bigger, but really try to keep this kind of small. So anyway, let's look at what changed as far as flow-wise versus the pretty rough finish to the smooth finish and kind of cleaning up the lines. So the 60 grit lost there, nothing there. 1 CFM, 2, 3, lost 3, gained 6, and gained 3. On the exhaust side, this has more to do with its completing more of the lines and smoothing them in like it's supposed to be, and that's probably the reason why it sees more of a all positive gains. But if you notice a huge trend here, you're not really gaining that much flow just by smoothing things up. I mean, it didn't pick up like 10. The best I ever see is pick up 6, and it picks up 8 there. So definitely on the exhaust side anyway, you at least do 60 grit. There's no sense in having a rough finish on exhaust. This, by the way, is without an exhaust pipe, so not bad flow. Picked up quite a bit. Something to be pretty proud of. So this is looking pretty good. Breaking 300 CFM, awesome. So anyway, there's those numbers. Now the last test I have for you is something you probably can't do on your own, and that is going to be doing a back cut. And I'll express this, that you could take it to a machine shop, and if they have one, they could do it for you. Anyway, that's the next test. Okay guys, this is Eric Wagner with Wagner Racing for one of the last things I'll do with this Kmj Assault Head, and that's change the back cut on this valve. So let me explain. I'm gonna get down here as close as I can. This is what the valve I've been using for all the flow tests. This has been a Brodix valve. It's a nice valve. It doesn't have an undercut. That's what it is. But it does have a 45-degree seat, and this is the back cut at 30. Not very wide. So what I'm gonna do is I'm gonna go over to valve refacer. And I know most of you can't do this because you don't got a valve refacer and they're expensive. I'm gonna take off some of this 45 so it reduces the margin. And the reason why I'm doing that is because it will leave me more material so that I can put a bigger back cut on. And what I mean by bigger is wider. I'm also gonna change angle from a 30 to a 33. And we'll see what it does. And we'll hopefully have some better flow results. I'm not doing the exhaust because I don't put back cuts on exhaust valves. This one already has one, but typically I don't, because yes, it helps slow the flow, but it also really helps flow in the reverse direction, which would be coming back into. In other words, it helps reversion having a back cut on the exhaust valve. So typically I don't have one, but this one actually does because that's how it came from factory. So back cut, flow again, and on to the next thing. Okay guys, just got done doing the valve refacing, so I can kind of show you. It's really hard to capture this on the camera, but seat angle at the 45. This was at 30. Now it's 33, and you can look how much wider it is. Okay, I could turn it so you can kind of see. Do my best here, but it's like if you have too low a light, it won't. You can't see it, and too much it gives you glare. There you go. Now you can see it there. The two angles. Boom. All right, I'm gonna reflow it, and we'll see what it does. Okay, now this is what happens with the back cut. So I changed the back cut on the valve. Brodix, although their valves are nice, they are not undercut. And I mentioned that in the video, but this is an undercut valve, which is kind of hard to see. But Brodix is, I'm trying my best to see it. I'm trying to do it against the light. Yeah, you can see there. See how it curves in? This is what they call an undercut valve. This means this part through here is usually thinner than this part. Now, Brodix uses a straight stem, so in other words, it never tapers down. The benefit to that is the valve actually gets stronger. The huge disadvantage is the weight. The valve itself weighs more. And I know you would think, well, this thinner valve would flow more, but for whatever reason, that Brodix valve most of the time outflows other valves. So, but the only thing that I don't like about it is, and I told you there, is the back cut. So, change the back cut, this is what it does. Now, I didn't do it on the exhaust, which like you've already heard. So this is what it does. And you're like, oh my gosh, you hurt things. Because if you look, I lost 2 CFM there. I mean, most of the points are negative. But if you look, that's hardly any difference change. That's not even 1 CFM. That is 1 CFM. But look, I gained 10 CFM at 300 lift. I gained 6 at 4. It's pretty good. Those, remember, my numbers I really care about in my mind are always the 4, the 6, and then the peak, which in this case is this number. So yeah, it looks bad, like as far as some of these, but I gained 10 and 6, and this right here is my meat and potatoes to me, for the most part. This one and 6. Now, granted, at 6, it only lost less than a CFM, and then it gained less than a CFM there. Lost 2 and lost 3. So it looks like an overall bad deal, but not really. I always try to put a different back cut on than it is from the factory. I can also say this. Depending on what valve job's put on the head will determine which back cut works best and how wide it needs to be. So it's not like a uniform thing. That's why whenever you get most valves, they'll have a 45-degree seat angle, because that's what most heads are, and a 30-degree back cut. However, a lot of my heads that I sell as far as they're on my website, and people have asked before, so I'll go ahead and pull out my card again, although I don't think anybody ever looks because they keep asking. Here's my card. Boop. Anyway, if you look at my website, the heads there, most of them are 50-degree seat, not a 45. Now, these are 45. That's common for 90% of the heads you see that are sold. They're all 45-degree seats. However, not everybody is. Some of them are 50-degree, and they're more racy heads, and this one's 45. But if you get any valves, typically they're a 45 seat and a 30-degree back cut. From playing around when I first got my flow bench, because I was on it all the time, I played with a bunch of different back cuts, and a 33 was the one that it seemed to like, especially with this valve job that I was doing. So that's what I've used since. It doesn't mean it's universal around the board, because there are some valve jobs that I will put on a head that if I do that 33 back cut, it's not as good. So there's other ones that work better. And sometimes you could put 2 back cuts where you can have, especially on this, is just to give you an idea, this is a high-end head where you have a 55-degree seat, you'll have a 45-degree back cut, and a 32-degree back cut. So you've got several. I've seen some circle track engines that come in and will have a 45, a 30, and a 15. I haven't seen a lot of luck with that. My preferred to, on this valve job I put on this head, is a 45, 33, and about 120 wide. So usually numbers, take the seat width and double it on the back cut. And this does bring up something else, because someone emailed me today, and I think they thought I was kidding. They said they had Manley valves. And Manley is not alone in this. I don't like Manley valves, and there's certain brands of valves I don't like, and it has nothing to do with their strength. It's more because of the flow. If you take a Manley valve, this is not a Manley valve. This is actually an AFR valve. But this is, most valves, like I say, come with the back cut already on them. But a Manley, this is the face angle here, right through here. It's so thin that you can't hardly put any back cut on. So typically what you'll have is just a 45, and maybe just a hint of the back cut will come in, because you'll add a material, because they don't leave any material here to really put one on. So it's not that I don't like their quality of Manley valves. It's just that I can't get them to flow as good as, say, a Freya or Brodix or Rev or SI or anybody's, really. Not that they're not strong. They just, to me, they don't put enough material to put a good back cut, and that hurts these numbers. So I got nothing against valves, and it's not all their valves, but several of their valves are that way. So I almost cringe when I see a Manley valve. I know they're strong. And by the way, you can have them make custom valves. They can put whatever you want on it. And also some of their other severe duty valves actually have a back cut on them. But so it's not all of them. but some of their lower lines for sure do. Anyway, there's that. This probably is going to wrap up this video, but I did do 2 other things. So just to kind of keep you little teaser or whatever, try to keep you interested. The next time you see this head, so this is where it's done. This head is done. Thank God, finally finished. It's been a long process as far as getting this done. However, the next thing you see is this is all flowed. Every test you see now has been flowed on a 4030 bore, which is common to your 355s, 383s. The next time you see a video, I'm going to do a comparison on how much flow you gain from a 4030 bore to a 4155 bore, because I've got another bore sleeve to do that. So I'm going to flow on that. I'll give you a hint, it picks up. And then the last thing you'll see, and this will be a totally different video, is me flowing it on my Superflow to see how it compares to my Sanyas, and you'll see it gain even more CFM when I do that, because I've already done these. But anyway, thanks for watching.